in the Super Bowl, by how many points does a winning team outscore the losers? Here are the winning margins for the first 25 Super Bowl games. So obviously, we've had a lot more since then. But for the first 25, the margins were the list that you see there. So what you're going to do, I'm going to have to turn this on for a second so you can see my calculator screen. And then I'll have to turn it off so you can see the iPad screen. So once your calculator's on, you're going to go to, one second, let me make sure I know. Nope, not that button. Stat. So you hit the little stat button here. And then you're going to see edit, which is going to allow you to edit a list. I would recommend using L1 because that's kind of like the presets for your calculator. And so if there's already numbers there, you can just type over them. If there's like a ton of numbers there, then I can show you how to clear the list. But and then you're just going to go down the line and type them in. So you just type in, so like 25, then hit enter, 19, hit enter, 9, hit enter, and so on and so forth. So you can type all those in. I wouldn't worry about it right now. And so obviously, since it's for the first 25 games, you should have 25 total numbers. So when you've typed in that last number, then you should see this L1 and then a parentheses 25. So that tells you that you actually have all 25 numbers. General rule of thumb, you want to always make sure that your numbers in your list are correct. But I just try to be really careful as I type them in, so that I don't have any issues. And like when we get lists that have like 40, 50 numbers in them, you don't want to have to check every single one. So just try to be really careful. But if you feel like your data seems really odd, then it's always good to check and make sure that everything's fine. So find the median. So what we are going to do is use our calculator to do that. And so right now you're going to hit second and then quit, which is this mode button. That'll get you out of that list. So now what you're going to do is you're going to hit stat again. Arrow 1 to the right, that's calc. And then this first option, one variable stats, is what we're looking for. So hit enter. And now it should bring up something that looks like this. You should see L1 already in as the list, unless you've ever used this before and you've used a different list, then it may put it up there. But normally it auto sets to L1, which is why I use that one. I'm going to show you really fast in case it's not that, or if you ever like, man, I accidentally typed my numbers into L2. I don't want to have to go retype them all. All you have to do is hit second stat, and that brings up your list names. And so then you can select whichever list it is and type it in that way.
Oh, you said second stat?
Second stat to type in the list name if it's not already there. But if it is, obviously you don't have to worry about that. And then calculate. So I kind of said yesterday, this is going to give you a lot of excess information that we don't need, but also a lot of information that we do need. And so this first thing is the mean. So if it asks for that. Down here is our standard deviation. The n equals 25 just tells you how many numbers there were. And then what you're going to notice is our actual 5-number summary down here. It gives us our min, our Q1. It's like I said yesterday, sometimes Q2 they call the median. And then Q3 and our max. And so the median is 17. So all we have to do is write that down. And then find the quartiles. Our Q1 is 6. Q3 is 21.5.
So we are always writing that when like it asks for quartiles, like Q1 and Q3?
Yeah.
Okay.
And then write a description based on the 5-number summary. So essentially, it's kind of just like in words saying what the 5-number summary tells us. And so I would say something like the fewest number of points a team won by was 1 point, because that was our min value. And the most a team won by was 45 points. Now, I'm just going to tell you that looking at that data, it's a possibility that 45 is an outlier because that's so much bigger than all the other data that we have. But we don't know that yet, so we'll just leave it be.
Can you like self-determine outliers usually, or not really? Kind of have to.
Sometimes, but also when we get to the outlier chapter, you'll see why sometimes something you may think is one isn't, and something that you might think, oh, it's close to the data, actually is. So I'm guessing that one could be, and I could calculate really fast and tell you if it really is or not, but that's not this section, so we don't have to worry about that. The median number of points a team won by was 17. And the middle 50% of teams won by 6 to 21.5 points. Now, obviously, you can't have a half of a point in football, but that's just the, like, kind of like the average, if you will. But you kind of see what I mean, where our summary is literally just stating the 5-number summary in words, essentially. Kind of like in context. It's a key thing that we do.
Is it saying 6, like through 21.5 points, or just 21.5?
Do what?
For the last thing.
It's 6 to 21.5.
There.
So basically, most of the, like, the margin that a team won by is in that range, because that's the middle 50%. It's from the Q1 to Q3 value. Because that's 25% from Q1 to the median, and then 25% from the median to Q3. So that's our middle 50%, which is what we care the most about. That's that IQR interquartile range that we talked about a little bit yesterday. All right, so this next problem, in March 2006, 16 gas stations in Grand Junction, Colorado, posted these prices for a gallon of regular gasoline. Throwback. So obviously this time I don't have nearly as many numbers as I did last time, so I'm going to show y'all how to clear a list now so that you can use Q1 again, or L1. Too many things. All right, so you're going to go to stat, and then this is where we would normally go to type it in, but if you arrow down, you see the one that says clear list. We click that. Now I need to call up the list name that I want to clear, so I'm going to hit second stat, And I want to clear my L1 because that's where I want to put this data. So I'm going to do that. So now it should look like this when I'm done. So clear list L1. And then when you hit enter, all it's going to do is tell you that it's been done. So the next time you go look at your L1, you're going to see that there's nothing in it. So now you can go to L1 and type in all of these numbers. Make sure you get those decimal points or it's going to really throw your data for a loop.
Wait, how do I type in L1?
Second stat. And then it should bring up your list options.
Oh, and that's where I would clear it.
Yeah.
Just hit the clear button and then it should just.
No, you have to hit stat, clear list, and then second stat, and then choose the one that you're wanting to clear.
Okay.
It's like, I'm going to clear my 3 because my 3 was full.
It doesn't matter which way we go, right? Doesn't typing matter?
No. And then you just hit stat edit to start typing in again. And when you're done, that last number should be in spot 16, so that's how many numbers we have.
And then where do I go for the data again? Like all the info and like unit and stuff like that?
But we're not doing that right now.
Oh, okay.
We don't need that yet. So the first part says to, let me let it refocus. Use your graphing calculator to make a histogram of the data and draw a quick sketch. So I'm going to show you how to do that. So second quit to get out of your list if you didn't already do that. Now up here above the y equals, it's really hard to see on the screen, but it says stat plot, and that's what we're trying to get to. So I'm going to hit second y equals, which brings up my stat plots. They should all be listed as off, or at least only one of them should be on. So if they're not off, then you need to hit the plots off button. But if they're already off, then you're good to go, which that's the default, is for them to be off. So I'm going to use plot 1. Really doesn't matter which one, but
How do I leave the list again? You said second what?
second quit. The mode button.
Okay.
So I'm going to turn on the calculator. And then I'm looking for this option over here that's now blinking, okay, that looks like, well, a histogram. Like a bunch of bars attached to each other. And you want to click that one. And then you want it to say XList L1 and frequency 1. Y'all have that?
Oh.
Go to second y equals. Y equals
Where?
at the very top left corner.
Oh, that one.
Alright, so then once you do that, you're gonna hit zoom at the top middle. Oh, nope, I lied. Second quit first. Then zoom. And you're looking for the one that says zoom stat, which is option 8. Nope, option 9. You're gonna hit enter. And there's your histogram. If you have anything in your y equals, it may freak out. So if
I had a
it's,
random line cutting across.
yeah, so if that's the case, then just hit y equals and then go clear whatever's there and then just hit the graph button again.
Wait, so you're saying once I'm here, what do I?
Then second quit
Okay.
and then zoom at the top middle
Mhm.
and then option 9.
Okay, there we go.
So all you need to do then is to take what you see on your calculator and basically roughly draw it onto your paper.
Do we need to have the little lines?
What little lines?
Like the little, what's the word?
Like these things?
Yeah.
No, just the boxes. If you were like hand drawing one, then like yes, but because you would need to obviously put labels on it. But this is just from the calculator. What do you see basically? And obviously it's not perfect, but it looks pretty similar to what I see on my calculator, so good to go. So the next question, some of it we can answer now, and then some of it we're going to have to go pull more information from our calculator to answer it. But what do you notice about the shape of this distribution?
It has one hump. So it's I forgot the last one.
Unimodal.
Unimodal. And would it be skewed right? Or
Yep, and it's skewed right because we've got this tail coming down this way. So it is unimodal and skewed right. Now, to answer the rest of that, the center and spread part, I need to go and do my 5-number summary. So that's going to be second stat. Nope, I lied. Stat. Getting used to which buttons I have to put. It's like I know, but I like most like say the wrong one. So stat calc, one variable stats. As long as you used L1, you're good. Frequency list doesn't get anything. And we hit calculate. And we're looking for that 5-number summary at the bottom. So I would say that my median is $2.27. Well, I'm going to say the 27.5 just because that's straight off the calculator. If it was, since it's money, if you rounded to 228, that would be fine. basically that's just telling us that I had two numbers on either side, and when I split them in half, that's what it got. So that's why it's like that. The minimum price that we see is $2.21. The max price that we see is $2.46. And then Q1 and Q3 tell us that most stations, if we want to be specific, 50% of stations charge between $2.25 and $2 and I'm gonna say 34.5 or $2.34.5. So now, do you notice anything unusual about this distribution that we found? Like, are there any gaps? Anything that looks like an outlier? No. But, let's see, remember yesterday I talked about sometimes we need to change our scaling on the x-axis to see if there is something. Let's look at that just in case there is anything that we would want to know. Let me try to focus this back in really fast. So, all right, so second quit again. Now what I'm going to do is I'm going to hit my graph button, bring that back up. But now I'm going to change the scale of my x-axis. So I'm going to hit window, which is up here beside the y equals button. And I am going to change the scaling. So if you go down, you see x min, x max, and then x scale. I'm going to change that instead of 0.05 to 0.03. Everything else will stay the same. And now don't hit zoom stat again. That just resets the whole thing. Just hit the graph button. And now what do you see?
You said hit zoom out?
No, I said
Okay.
don't hit zoom again.
Okay.
There's an outlier. Or would it be, because there's two gaps between that, right?
Right, but that doesn't necessarily imply that it's an outlier.
Okay.
But you see gaps, right? So if I were to look at this, I know that my minimum is what, 221. And these are supposed to be increments of 3 cents. So going up, basically what this shows me is if I count going across that from or in this region, no station charged between $2.40 to $2.44. If I counted by increments of 3 cents each time. Like 21, 24, 27, 30, 33, 36. But that's going to actually put me at 39 at the end of that column. Because the 21's at the start line.
And how do you know it's going by 3 cents?
Because I changed my X scale to 0.03.
Okay.
It was 0.05 before.
Okay.
So that tells me that by changing the scale to 0.03, we see a gap in our distribution. No station. Hit 1 second. No station charged between $2.40 and $2.44 per gallon. Hey, sorry, I was trying to finish a problem really fast. Okay. Okay. I got in touch with Coach Hopkins, and he said they would get it taken care of today. Because I told him, I said, either you can do it at the game, or I said when you come to pick your other kids up, you can do it. Just stop by the office then and do it. And even if we've already left, that's fine because it'll still be on file here, even if I don't have it. And I can just get an updated copy before Thursday. There was one thing else I think I was going to ask you, but I'm not. Oh, if I have old ones, should I bring them to you to shred? Okay. Sounds good. Okay. I should have time probably next class. So, awesome. Thank you so much. All right. Bye.
This might sound stupid, but how did you get that it was 240 to 244?
Because that's where, like, the gaps are. So this was 21. So this would have been 24, 27, 30, 33, 36, 39. So basically, because there was one, I think that was 239, or was there? 239 is like included at the edge of that. So then there would have been one in here, which would have been, what, 42, and then this one would be 45. So it's like the part that's not included in one of the like bins or whatever. So 40 to 44 isn't included in either of the bins that we have.
How did you change your graph to 0.3?
I hit window,
Uh-huh.
and then I went to X scale and I changed it.
Okay. And why did you do that? Like, what was the reason for
Because I wanted to see if there were any gaps, anything unusual. It asked me if there was anything unusual, and I didn't see anything. So when it asks that, my reaction is, they must think there's something unusual, so I should go check.
How far away would it have to be for it to be an outlier?
It really depends. You can't necessarily just look at a histogram and tell. You'd pretty much have to do the calculation to see. I mean, if it's like way out there, obviously.
So like if it's a value above your maximum.
Like if it gave us like $3, I'm gonna know that's an outlier.
Okay. So if our maximum was 246, if it's anything above that, then it would be an outlier?
No, not necessarily. That was just our max value.
Okay.
I can calculate and tell you what outlier would be for this one. It would be anything above $2.72 would have been an outlier for this one. Or below $1.87.
And how'd you find that?
We haven't learned it yet. I was just telling you since you were asking.
Sounds good.
I don't want to confuse you too much yet. It does sometimes blow my mind that they don't teach it when they teach this. However, they're just trying to get you to start thinking about it, and then mathematically in the next, I think it's next chapter, we do it. It's a super easy calculation, and so I could just do it right there. All right. Next one. This one, in case you want to note it, this is number 6 in the book. I didn't ever fix it on my sheet to write that, so. Would you expect distributions of these variables to be uniform, unimodal, or bimodal, and then symmetric or skewed, and why? And so I would draw like a little picture. We're not going to draw it as a histogram. I'm just going to draw it like as like a distribution, like a visual. So so that we can see it. So the first one is the ages of people at a Little League game. What do you think this one would be?
Like the people playing or just everyone playing?
The people at the game, so everyone.
Maybe skewed.
Maybe skewed. What shape do we think it has? Uniform, unimodal, bimodal.
Uniform? I mean unimodal
Why so?
because like it's going from young people to older ones, so maybe like
Just like one hub.
maybe
Right.
So who all's normally at a Little League game?
the
Kids.
players, the parents, the coaches.
Maybe some grandparents on occasion, right? Obviously, you know, we could go out and go crazy and be like the friends and all this other stuff, right? But typically, would you agree that overall, most kids have parents around the same age? So, like, I mean, overall.
Oh, you mean like the parents are the same age?
Yeah, like
Oh,
the
okay.
parents, like all the parents of, like, you know, the 8U team or whatever, that
Yeah.
they're all kind of similar in age. Obviously, there can be some exceptions. But you would say, okay, all the parents are, like, in their 30s, but all the kids are, like, 8 to 10 years old. So what about that middle ground? And obviously, there could be a few siblings or something that are older in there, but there's a gap in there, right? In terms of who we would expect to see. And then if you saw some grandparents, there's probably not as many of them, but obviously they're going to be probably at least 20 years older than the parents. So I would tend to say with this one that it's bimodal because you have the kids, you have a lot of kids, and then you have a gap, kind of. Then you have a lot of parents, and then maybe it skews off just a little bit with some grandparents that have come to watch.
Oh wait, so you wouldn't be making the chart like?
No, I said I wasn't making it like a histogram.
Okay.
I think that's still what I was thinking in my head.
Yeah.
Even though I know you said that, like that's what I was picturing.
I mean, I could have done that, but that seemed excessive when I can just draw it this way. So I would say bimodal and maybe skewed right. Now, what I'm going to tell you is if you see a question like this on a quiz or a test, what you should do is you should explain why. Because if you had said, oh, it's unimodal, and you had said, well, there's just kids and parents there, kind of thing, then I might have kind of understood where you were coming from, if that makes sense. But, like, so make sure you explain why you choose what you choose for something like that.
I'm still kind of confused on like what that's even supposed to mean. Like, is it like amount of people? That are,
It's
that
like
would
if
be,
you did the histogram. Everything has, like, the number of people in there. So this is saying there's a ton of people around the same age here.
Okay.
Then there's only a few in this middle age that you could say you have a really young parent, you have an older sibling, whatever. Then you have all the parents that are kind of around the same age, let's say, you know, late 20s,
Okay, so it's not like
30s.
age range. It's more like how many people are a certain age.
in that age range, yeah.
Okay.
So if we did like increments of 5 years or 10 years or whatever, and we said, well, like this is like 0 to 10, and that's where all the Little League kids are coming from. But then this 10 to 20, there's like next to nobody except for maybe a couple siblings. And then 20 to 30 or 30 to 40, if we wanted to split it that way, like that's where all the parents are, because that's like the age range for parents, you know what I mean, for like that age. And then this like extra little tail over here would be like if there's grandparents or something like that that are coming to watch, because obviously at a Little League game, what grandparent wants to miss their kid play, their grandkid playing?
If this was like a test, would we have to like label and stuff, or like only if it asks?
No,
Okay.
you just do it just like this. This is all the book is looking for. The next one, number of siblings of people in your class. What do we think about this one?
it be kind of skewed because like there could be people with 0 and then 1 and then I don't know.
Yeah. Because, I mean, statistically speaking, about how many kids you think are in an average family?
3 on average maybe.
Yeah, probably like the 3 to 4 range, right? But obviously, it's going to be a lot more common to see 1 or 2 versus like 5 or 6 siblings. Obviously, there are exceptions, but I would tend to say that there's, you know, probably a small amount that just have 0, and then, you know, getting out into here is probably where there's like 4, 5, 6, so on and so forth siblings. So this huge area at the beginning where it's like probably 1 to 3 siblings or 1 to 3 kids total, however you want to think about it, that's probably the most common like area, right? So this one would be unimodal and probably skewed right. Now, if this was back in the old days, it might actually be skewed left because, let's be real, they had a lot more kids back then than people do now.
My dad has 8 siblings.
That's crazy.
8 siblings.
Can't imagine that.
Mm.
All right, the next one, pulse rates of college-aged males.
This stuff is gonna throw me off because I can like, I don't know, like it makes sense, but it doesn't make sense until like you draw it. If that makes any sense. Like I can't like picture it in my head, but then like once you do it, I'm like, I don't know.
Is it saying like? I feel like I like think about it too much because obviously it's gonna be different with like people who are active. I feel like and not, but could it be kind of uniform?
This one, well, maybe not uniform, but maybe symmetric.
Okay.
Because obviously you've got your super, super active, really low pulse rate, but then you've also got your very much couch potato people that their pulse rate's higher, right? And so, but then you also have the people that are kind of that middle ground where they're like kind of active, but also kind of like just chilling home kind of thing. And so probably have like a pretty normal heart rate. And so I would say it's probably pretty fair either way. But this, again, is one where you could possibly argue it a different way, and that's why you'd want to give your explanation with it.
Can it be symmetric and unimodal or no?
Symmetric is going to be unimodal.
Okay, that's what I thought. Would you put unimodal still, or would you just put symmetric?
Yes,
Okay.
unimodal and symmetric. Because you could potentially be bimodal and symmetric, but it doesn't often work out that way.
And symmetric won't have it skewed, right? Like it would just be.
Symmetric can't be skewed.
Right.
Because it has to be the same on one side as it is on the other.
Yeah.
So for that one, would it be like the like active people are the most, or like the average people, and then like the active, then the couch?
Like average would be here, and then active would be over here, and then like your couch potatoes would be over here.
Okay.
All right, this last one. How about the number of times each face of a die shows in 100 tosses? So, you know, like a fair 6-sided dice. What would you expect to see with that?
That's so random. I don't even know because it's like, it's all like up to chance. Maybe uniform. No.
So think about if you flip a coin, what's supposed to happen? How often are you supposed to get heads versus tails?
50-50.
50-50, right? So in theory, if you have a 6-sided die that you roll 6 times, what should happen?
Take a 1 in 6.
Yeah.
Yeah, everyone has a 1 in 6 chance of being rolled, right? If it's because it's a fair. Now, obviously, 100 doesn't divide by 6. So there is some level of that. But in theory, what should happen is that they should all be equal. And so what you said about it being uniform is actually correct with that one.
Oh, okay.
Just wanted to make y'all think about it a little bit. And so if I do uniform, I would just do something like that where it's, you know, basically the same all the way across and all you have to say is uniform.
Are we gonna have questions like this on the test, or like?
Possibly. One thing, we kind of had it yesterday in the notes, but it's always good to rewrite it again because people tend to forget this piece. Skewed right, the mean is greater than the median.
Did it answer it? No, okay.
Is it calling the cops?
Say what?
I said, was it calling
I
911?
hope
Oh my
not.
gosh,
That's happened to me so many times.
Skewed
twice.
left is mean is less than the median. And then symmetrical, the mean is approximately equal to, that's what those little curvy equal sign means, is approximately equal to the median. You will want to make sure you know that because there are going to be times where we're going to want to know what to use, and it's going to be based on that. So if something is symmetrical, we want to use mean. If it's skewed at all, we have to use median because it's going to be more accurate for what we're looking for. As far as the rest of the problems that I had on there for us to go over, there's not like a ton. We should be able to get through them relatively quickly tomorrow because they're more conceptual type things. So if you want to start on the ones that specifically say homework, but the ones that are examples, we should be able to finish tomorrow because I think it's literally like a page and a half or something before the homework starts. So, because I know you were going to try to possibly take the quiz ahead of time on Thursday. So we should have enough stuff by tomorrow that you could do it Thursday if you wanted to, but if you feel like you need to wait, that's okay too.
Okay. If like